who owns Bitcoin or any other cryptocurrency at the moment? Shit. Yeah, okay, cool. What about, who knows about Hyperledger, R3, those programs? Yep, okay, cool. So for you guys, I guess this is probably going to be covering off a piece that you might know for a reasonable amount already or not, but I'll try to keep it in line with everybody's kind of knowledge. So, state of blockchain. Just to cover off the basic end of it, the way you would kind of describe the blockchain ecosystem is imagine multiple computers or entities keeping track of a transaction or multiple transactions and keeping updated amongst a distributed ecosystem. So instead of one entity holding all the information and being the piece that shares it within everyone else, then you have a distributed network of it. But in order to kind of really display that, I will explain it through a bit of a story, which is probably quite useful, which actually doesn't involve computers. So blockchain solving a different kind of prisoner's dilemma. What's happened here is this is Charlie Shrim. So Charlie Shrim went to prison at the age of 22, and he went to prison for being involved in starting up this organization called BitInstant, which is basically a money transaction and dealing with as a brokerage type entity for Bitcoin. And what he did was he dealt with a broker who engaged on Silk Road, which was a famous, I guess, dark website which used Bitcoin to illicit drugs. And in dealing with that broker, he was sent to prison for a period of time. Now, what happened when Charlie was in prison was he effectively couldn't engage in commerce through the use of money because they're not allowed to use money inside the prison. Now, when you're inside the prison, what would happen is if you want a haircut, the guy who cuts your hair might want, butter or peanut butter, or the guy who fixes the headphones, this is Charlie's words, he might actually accept protein bars. So what you would do is you go to the store and you would trade and buy it from there, and then you would then give the person and trade for goods. But then he also added, in prison, they basically accepted mackerel. So this was the form of currency that was used within inside the prison. And people accepted mackerel not because the mackerel was, everyone wanted to eat fish, but basically they accepted mackerel because everyone else accepted mackerel. The problem or the challenge that they faced was you couldn't exactly hold large quantities of it. You had to basically carry it around with you, so you're not going to exactly carry cans of fish everywhere you go. What happens if people steal it from you? You can't trust the other people in the prison, and basically it creates an issue for you to hold this sort of currency. So what he did was he introduced basically blockchain to them. And in the prison system, the way he introduced blockchain was not actually through a computer, but he did it the old school way through pen and paper. So what you have is an environment where people don't trust each other. You're worried about like somebody's going to rob you, and you need to keep hold of your mackerel or your currency. So how do you do this in an ecosystem that's more challenging? So what he did was you have various bookkeepers from different cell blocks, all keeping track of each other's transactions. So what he would do is you would have, say, somebody from cell block A, a multiple group of people from cell block A keeping a ledger and writing down the transaction of, Johnny cut, Andrew's hair, and he owes him like 1 mackerel. And that person would then go to the bookkeeper and keep that transaction ledger. And then this would occur in each individual cell block. Now, at a weekly basis, what happened is each of these bookkeepers would then come together and then copy each other's transactions from each other cell block. So what we would have is the bookkeeper from cell block A would now hold the information from cell blocks B, C, and D, and the bookkeeper from cell block B would now hold A, B, C, D as well. And then what that does is you end up solving this system where if you're worried about your mackerel getting stolen, it wouldn't really happen as much because, you have a bookkeeper who's basically keeping receipts of this piece of information, and you couldn't artificially inflate and say, oh, I wanted to give myself 1 million mackerels and say I'm mega rich in the prison, because when those bookkeepers would then meet with the other bookkeepers, they would effectively have the same records of your transactions. Say like, wait, how do you now have 1 million mackerels? Because last week when we met, you only had 5. And this would keep these checks and balances in an ecosystem that was basically didn't have a central entity to trust the bookkeeping for it. So what he really brought to them was a trusted system of tracking and value transfer without having a third party in between. So when you have that, it kind of really sort of revolutionizes the idea of like what this could mean for mankind in the like a longer term perspective. Because in order to engage in business or in commerce, we have basically, the world has a $1 trillion relationship in terms of transactions and trust, but in order for that to happen, you need to kind of know the other person you're dealing with. Otherwise, why would you engage in business with them? So in this ecosystem, you can now do it without necessarily having to trust or know the other party. So I guess I'll kind of run through this really quickly since most of you guys probably know this, but the current system is most databases and ecosystems run through one central entity, and then that entity then distributes that information to everybody else. So you're a bank, you hold the information for all your customers within yourself, and then when they want to get access to information, you share that out. If you visit Facebook, Facebook has all that information. Even if you go to the stock market, the brokers, they hold one central entity, or say the New York Stock Exchange holds the value or the pricing mechanism for all the stocks. And then in a distributed system, which is where a lot of the blockchain space plays in, it's more distributed. So basically you don't engage through that central entity, but you have a peer-to-peer type relationship between everybody. So in Charlie's example, this was great because you could do that with pen and paper, and you could engage with each other, but there weren't a lot of transactions happening, and it didn't need to scale because there was only a full handful or a couple hundred or so transactions that needed to be recorded and distributed amongst each other. How would you do this if it was online, and how would you do this if it was at a wider scale? That becomes more difficult. So that's where, when computers come to play, Satoshi Nakamoto invented Bitcoin in 2008, and he actually solved a real fundamental problem, which was called the double spend problem. So the way to think about it is the double spend problem would be if everybody's broadcasting information, in like Charlie's example of like I've made like 100 transactions while I was in prison, it would be difficult if the bookkeeper didn't know which transaction was first and who was right in terms of you spending your money. But luckily they wouldn't have that issue because there wasn't a lot of transactions. But in the internet environment and where anybody can transact with anybody, you need a different mechanism for this. So Satoshi Nakamoto implemented a concept from Dr. Adam Back, which was proof of work onto combining different components within the Bitcoin ecosystem to basically produce it. So Bitcoin would be considered that same scenario, but basically the world's first digital peer-to-peer piggy bank, personal piggy bank, really. Because you own the money yourself, you don't need permission to basically engage in this ecosystem. You're basically able to engage in a different monetary means without having to go through any real entity or central entity. So the way it was different is it's permissionless, so nobody asks permission, you can just basically engage with it. Most of the times, back in the day, you would like physically do hand-to-hand deals with people. Or the very beginning was people-minded, but it's generally unconfiscatable, so the same sort of scenario within Charlie Shrimps in the prison, you're not necessarily holding that mackerel anymore, but you have a digitized version of it. So in this example here, it's rather hard or difficult to confiscate, other than you having to hack the person who owns it. It's immutable, so the blockchain itself means that if everybody's recording transactions within each other on a continuous basis, it's very difficult to backtrack and then re-edit it, unless the system that is built for it allows you to do that. But within the Bitcoin ecosystem, you can't. It's global, it's divisible, it's uncorrelated to any other monetary system, and the interesting part is nobody owns it. So if you lose your money in this ecosystem, basically you've lost it. There's no one to cry to, there's no business, there's no nobody to blame. You can't really pinpoint any location to get that back, and that both creates an interesting scenario, because if there's no one to blame as well, then like if you lose it, you don't have anyone to blame but yourself. So it's kind of a responsibility on yourself, and when you're responsibility of your own money, like people tend to take security really interestingly and very different. So what was interesting is a lot of the 2000 to 2009 to 2014 period was around blockchain and Bitcoin being one and the same thing. It wasn't really discussed as much as being different. But then from probably around 2014, 2015 onwards, the narrative sort of really started to become different as businesses like IBM started to look into the space and say, well, what happens if I did that Bitcoin thing but took the blockchain part, and I don't want these other other pieces around it that I can't really control as much. So what they would do is they would look at their own infrastructure, and they'd say, well, we're kind of centralized like this, and banks actually, in order for them to engage with each other, they need to go through a clearinghouse, and that clearinghouse is an independent third party. But then they would kind of conceptualize, well, in the Bitcoin ecosystem, everybody just engaged with each other. So how, they wouldn't really want to play in that space. But what if they could cut out the middleman in between? So the SWIFT network for the banking system basically controls international monetary transactions between different organizations and different banking systems, and basically between nations. But if you didn't have them, what if you applied something like blockchain, where they would be the banks would be interacting with each other? Because the banks don't necessarily trust each other as well, but now they would have a mechanism where there's no one central entity that controls it, but they would be able to engage. And then having the other side of it is actually really expensive to do it and engage with the SWIFT network itself. So that's just kind of like the conceptualized stuff that would start to emerge out of this ecosystem. Whether or not this ever plays out, maybe not, but it's the types of stories that would apply within how would people's or organizations start to think about blockchain without actually interacting with the cryptocurrency ecosystem itself. So if you end up with that space where all these different organizations need to interact with each other, then you kind of have this problem, because everybody's writing code, and what would happen if the code is all different? Then there's no interoperability. So you can't have your business say, okay, I've done it, I'm great, everyone start to use my data. They'll be like, no, I want to run it a different way. So you end up with a means to solve this by most organizations, and particularly in the Fortune 500 space, they look at consortiums. So the Ethereum Enterprise Alliance, that basically focuses on Ethereum, which is the second largest cryptocurrency in the ecosystem. And that mainly focuses on smart contracts. So you have like a distributed computer, basically, and you can write on top of the underlying base code itself, like different rules that you would want to add on top of it. I'll walk through some examples a bit later. And then there's Hyperledger, which is basically started via the IBM guys, and they make it open source, and it's part of the Linux Foundation. R3, which focuses on like the financial sector, kind of like, if anyone knows what Ripple is, plays in that sort of space. And then you've got Consensus, the organization, which is like a blockchain services company. The guy who's the founder, the CEO, Joe Lubin, he is actually a co-founder of Ethereum itself with Vitalik Buterin, who started Ethereum. And then on-chain is very similar as well from a financial sector, but it uses parts of like what Hyperledger as a blockchain ran as well. So basically, now you have all these different like consortiums come together, but then it's like, well, who's actually involved? And you think, oh, well, great, Accenture's there. But it's not really just them. It's actually quite large. You have like top names of organizations like IBM, ING, BP, Pfizer, the CME Group. They just recently patented a rule where they said, okay, we've developed a blockchain methodology but you can now rewrite the contracts in history. So kind of like a distributed database, but they still have control, which is a bit interesting. But it can understand why they would want that, because if mistakes occur, you can't leave it indefinitely incorrect. Baidu out of China, which is huge. Cisco, And then the list kind of just really goes on. So the Ethereum Enterprise Alliance alone has, let's see, 200 plus members or organizations. And then the Hyperledger ecosystem itself has got about 183 plus at the moment. So what are they really all trying to do? These are all like hypotheticals at the moment. Most of these groups are basically doing pilots, but this is both in the consortium ecosystem, but also outside of it in terms of businesses themselves coming up with these ideas. Imagine authentication for a second-hand resale of luxury goods. So if you say you have a high-end luxury like handbag per se, let's say it's a Hermes handbag. You buy a Hermes Birkin handbag, which is like 50 grand. And then you want to resell it. How do you ensure the authentication that this reseller is actually an authentic bag? Like you already have massive issues where China mass produces all these fake handbags and they just resell it and then you realize you don't have the real thing. So what happens if you had a partnership where Intel could develop chips and they had a connection with RFID component or some other mechanism to confirm that there's an authentic a limitation on the bag itself that gets embedded in the bag, and then that means when the transaction would occur, you can track it from the manufacturer, where it starts from, to the delivery man, to the front retail store, to the warehouse, to the main retail store, to the first customer. And that when that first customer sells it, that first customer can then understand that that handbag is actually had only one owner and that it's purchased at XYZ period. They could control the ecosystem to say whether or not it exposes the person's name, which it probably wouldn't, but you could do a means of authenticating without actually having to trust that the person who's selling it to you is actually owning the real bag itself. And then you could have a system where car default loan tracker. So in loans for cars, basically you have this issue where people finance their car, they buy a car, and then they default on the car, and then the organizations basically have this issue where like, well, how the hell do I find out where this car is because I need to repo it and get my money back? Imagine if they had a system where there was a tracker on the car, but they would only ever activate if your financial situation was not repaying the bills in your monthly installments on time or something. Then that could be a piece of information that would be shared, and then you could be running back. Insurance and automatic payouts for shipments or flights. So you're going on an airline. It's very important that you constantly connect your flights. You can buy insurance against that. Now the problem is if the flight gets cancelled or it gets missed for whatever reason, you have to contact the airline. You have to then prove it was cancelled. Then you have to provide all this information. You have to deal with the other person on the other phone. What if there was a system where, in this world, you would basically get paid out immediately in the cryptocurrency or whatever tokenization that represents that value transfer in a smart contract immediately? That means as a customer, you would probably not have to worry as much as, oh, the business that I'm working with won't pay me out because it's written in the code. They can't actually control. There's no third party on the other side where maybe the person you ring up the airline to ask for your insurance back doesn't actually put through your process. It just occurs immediately. And then auction-based resale for electric goods. So this is actually something that's begun. It's a partnership within Origin as well. It's called Power Ledger. But basically, electricity grids are run, and what happens if people have excess capacity? The hypothetical scenario is, at the moment, it's bought bulk back into the grid itself, and the government or those suppliers actually buy it back. Well, you could actually have a market ecosystem now where people who stockpile large amounts because they're good at saving their energy grids, they could basically resell it to their neighbors or so. That would be quite a long process to go through, but it's a hypothetical scenario. Airbnb blockchain, when you go and do your Airbnb, you basically have to get to the house, and then the person on the other end needs to give you the key, and they need to meet up with you, and then they need to ensure, okay, well, here's the key, and then when you leave, that you get paid out. All those steps require lots of interaction between the buyer and the seller. If you had an ecosystem where it would require, like, you have multiple blockchains that could speak to each other, imagine, we have electronic doors where people use keypad pins, or that they could tap their device against. Like, If anyone has a Tesla, you tap your phone or your key against it, it kind of like opens the door. In this ecosystem, you could write the code where the tapping of your phone or your RFID against the door both unlocks the door and pays the owner of the actual asset itself. So I could run an Airbnb system, and as soon as the door gets tapped, that means I know only that person who I've allowed to get to the Airbnb is entering my house, and also it automatically pays me. Like it just, if I use Ethereum, for example, it would write the code that says it just sends me Ethereum to my wallet. And as long as I think, just like in the prison scenario, where mackerels are valuable because everybody else accepts mackerels, if I accept Ethereum because I value Ethereum because everyone else values Ethereum, then that's where the ecosystem would be kind of acceptable. And then this is a really blue sky thinking idea where you have e-wallets for self-driving cars. So we're heading down the route of, like, imagine like 20 years from now, you have cars that can drive by themselves. Imagine in this space where like the cars or the machine itself can own a bank balance or like take control of its own money. So you never have a scenario at the moment where a machine actually owns the money itself. You have somebody who's a custodian who owns the account and then controls the direction of the money. But just like a ATM, or not ATM, like a vending machine, when you put money into the vending machine, all it knows is to accept it and it keeps it and then it spits out the change. It has like a very simple function of if $5 goes in, I need to give like $1 back out in change plus drop the chips. Like that's its function and rule, and that's what it is at its core. If you had this, but imagine it at like a larger scale where you have self-driving cars that drive by itself, and then it says, oh, I need to make sure I save X amount of balance on my like car wallet, and then drive to the wherever they get their electricity battery pack recharged, and then that would automatically pay out to the service station and then drive back to wherever it needs to go. Then you've got a system where a machine is actually deciding to spend the money itself without a rule set of somebody having custodial ownership of it. And then the beauty of this whole ecosystem is it's open source. So not everything is open source, and lots of the CME guys patenting their blockchain version where it's only reversible is patented by their own side. But a lot of the ecosystem and the starting foundations for it are open source. So the interesting part about it is when it's open source, you kind of move at light speed. It means anybody has access to the information right away, and there's no barrier entry to basically engage in this ecosystem. And just to show you how fast it is, I mean, if you guys, a fair amount of you said that you know what Bitcoin is, does everybody know what an ICO is, or ICO? Yeah. So an ICO is basically like in stocks, is they call it initial public offerings. So like when Facebook gets listed, it says we're offering X amount of shares at this price. You have to buy at this price in order to own a piece of Facebook. Sort of like that, but without the rights to own it per se. It's tokenization. It's a bit blurry, but it's basically like a fundraising mechanism, but on a global level, without any rules for how you can be funded. So this is kind of an do I need to press the next slide?
Yeah, just press the next one.
Yeah, cool. So this will just show like how fast and rapid this ecosystem grows and why there's this sort of like hype towards it more than recently. Maybe just change the speed. So this is 2014, so you have the first, the bars on the left are basically by country, and Ethereum is the first like real well-known ICO. And then after Ethereum, you have the DAO, which should appear soon, which was basically an idea for a decentralized organization that makes decisions without a central body that decides what it is. It should come up. There it is. And then now we're basically rolling into the end of 2016. We're just about to enter the start of 2017 now. So each of these bubbles represents a different organization basically fundraising for money. And this money isn't small. Like you basically, if you think about it, you have, there's this like companies called like Bancor or Tezos. They're fundraising like $250 million without a product. You basically go out to the internet and just say, I want some money to build something. Oh yeah, give me $250 million. Oh great. Like that is never really been seen or thought of before in history, because well, who gives somebody $250 million without them producing it? Some of these organizations raise like tens of millions of dollars, and they don't even have anything written down for how they would structurally deliver something other than, I think I have an idea on how I could do something, give me some money. So that's why this ecosystem can be a bit crazy, but it moves at light speed because you have this ability where people can copy from each other and then play off this ecosystem. I think you need to press it again so I can go to this slide. So the issue with this rapid innovation is basically what happens is security can get missed, and security on all levels. So this is a more recent one, but the most obvious one is an exchange. So this is Nano, which used to be called Railblocks, and they got hacked for $170 million. Basically that's the equivalent to saying like, hey, I bought some stocks on the stock exchange. By the way, those Facebook shares I used to have no longer are mine anymore. They got stolen and I can't get it back anymore. That's the equivalent for what it really means. This is the DAO. So there was $50 million hacked from the DAO. But this is different because this is getting hacked at the protocol level. This is basically the developers writing code and somebody finding a flaw in the code and saying, hey, I can actually withdraw funds from this thing and just recycle it constantly and just give it to myself when the coders didn't actually think that somebody could perpetually recycle and extract money from the account, which they don't actually own anymore. And then you have $60 million worth and stolen from miners. So this is even another thought of it is like in the Bitcoin ecosystem, you have miners, which are meant to be the guys who run the security. They basically secure the blockchain itself by ensuring that you can't reverse, you basically have to brute force your way to reverse the previous historical transactions. And they themselves got hacked as well. Then you have hundreds of millions of dollars basically frozen in a wallet, and this is one that happened last year. It's a multi-signature wallet with the wallet provided by Parity. So basically, somebody provides you, think of it like a bank account, and the bank account allows you to interact with, it's shared between your husband, wife, and kids or something. And then the bank account actually deletes your account by accident or deletes the ability to access and move funds on that account, and now your money is stuck. That is the equivalent for what's kind of happening in this ecosystem, except it happened for Ethereum, but the guys who implemented it, Parity, basically accidentally deleted a line of code, and that deletion of that line of code meant that their money is now stuck. NEM, which is a token that's basically used for financial banking services, mostly out of Japan. They had $250,000 basically stolen them, and that's basically banks in Japan who use it as trial products will be wary about it because now you have $500 million, sorry, now missing. And the list just goes on and on. Like, it's sort of relentless. So with that, you have, like, security sort of needs to be at the forefront. Like, ensuring that it's secure and safe needs to be at its end. So I work at Commonwealth Bank, and I know that the apps we have are really quite seamless and really great. And if I just remember, like, if I want to access my bank account, I literally just take out my mobile phone and press my thumb against the home screen, and that opens into my account, right? It just registers it, and it's just, bang, I'm in my wallet. I'm in my bank account. If I was to do this in the cryptocurrency ecosystem, this is what it looks like. And this is for a customer and their customer journey. First, I go to the website, and it tries to determine if I'm phishing or if, what's basically happening. Are you a legitimate customer coming to the site? And then it says, okay, give me your email address and password, except it's not one of those nice passwords. It's like 12 characters long. I need a special character. I need capital letters. I don't even really remember what it is. And then I need to basically do a recapture scenario and basically play, which one of these pictures is a bridge. And I have to do that like 3 times. And then I basically have to do authentication. So if you used to have like a laptop that you would take home, sometimes you had like a dongle that would have a random key generator assign it to, say, a random number that you would assign to the laptop so you could then log into it. It's like that, but it's on your phone. And then after I put that in, then it basically says, oh wait, I don't recognize this IP address. Can you go to your email address and then ensure that this IP address is authentication and right to go into it? And then when I go into it, it basically just takes me back to step 1, and I'm still not even in the site. And these businesses and organizations actually do this intentionally because the cost for them on the other side to get broken into and the security factor of it is extreme. So this is just for them on a customer-facing level. Imagine what it's like on the back end. So I guess in conclusion, the space is just new. Like nobody really knows what's going to win. It's at the layer where you don't even know what protocol is going to be the space that takes the dominance of what is going to happen in the future. But what you will know for sure is there's going to be a lot of failures along the way. And I mean a lot of failures. During the electrification revolution, so when light bulbs were made, all these appliances started to come out because you could have electricity in the household. On the far left is you basically warm your tie. Don't know why you would ever need that, but it's always going to be tried. The second one there is you basically warm your shoes. So you plug in an appliance and then you warm your shoes because you're always getting it wet from the rain or something. And then the internet revolution, pets.com, broadcast.com, webvan, all these are massive and great examples of failures. But the interesting thing is some of these failures actually are not failures because of what their idea was. They're failures because they're actually too early or they're too soon. Broadcast.com, which streamed basically YouTube for the internet, was doing that in the year 2000, but the bandwidth wasn't ready for it. But the idea was there that people wanted to watch content online. And Webvan is just Amazon now. Amazon delivering food to your doorstep was the concept for Webvan, except the company that does that now is the global behemoth in the world. That's it. Thanks.